Hello everyone, I'm here to go over the Honors Chemistry Midterm Exam review with you today. Let's start with number one here. What is the safest way to make an acid solution by mixing it with water? Well, you want to pour the acid into the water, okay, slowly, of course, to avoid it from splashing. Sometimes people also use the glass stirring rods and pour the acid kind of down the stirring rod so it trickles into the water, again, to help avoid, let's say, with splashing. There we go. All right, our next one has to do with converting. We are moving a number from liters to milliliters. All right, so for this one, the easiest way I can tell you to do it is just to move the decimal point. And you have to remember your the prefixes for that. Let me show you real quick if you may have forgotten. But, you know, here we got kilo, hecto, deca, and you have your base units, which are liters, meters, grams. And then you go to the smaller end with deci, centi, and milli. And I tell my kids to remember this by thinking King Henry died by drinking chocolate milk. And that matches up with, you know, your prefixes, your large prefixes on down to your smaller ones. So we said we were starting with liter, which would be a base unit, and we want to move it to milliliter. So you move that decimal point how many times? 1, 2, 3. And you're moving it towards the right. So that was pretty easy to do if you can remember that chart. Okay, so we started 1.25, we moved it 1, 2, and you have to add a 0. So we added the 0 here to the end to make 3 spaces, and your answer is 1,250. Okay, just remember when you're moving the decimal point, sometimes you might have to move it in the other direction, just whichever way you have to move it using the prefixes on that chart. That would be the way that you would move your decimal point. You find out where you start and where you need to end up with. All right, number 3 is a multi-step problem. You have got to remember how to determine density for one, because it says according to the following data, calculate the average density for sample X in significant figures. So you got to remember those rules too. So let's go back to my sheet real quick here, because I've got lots of information. Okay, so first of all, that chart says you got the mass in the first column, but the second column says displacement data for sample X. Now remember your water displacement method for determining volume. That's when you have an irregular shaped object, you can throw it in a certain volume of water and then calculate how much it displaces that water, and that will give you the volume of your irregular shaped sample. And then, of course, matter is measured in grams, and then density is mass over volume, mass divided by volume. Some of the other information you need to answer that one were your sig fig rules. If you remember, any number between 1 and 9 is considered a significant digit. Any zeros that are sandwiched in between 1 through 9 would be considered significant, such as 1002 here. Those zeros would be considered significant, as well as the 1 and the 2. If you have a 0 that's to the right of a decimal and a significant digit such as this 0 here on the other side of the 1, that one is considered significant, but these zeros that are leading zeros, which we call placeholders, would not be significant. Okay, so you just got to remember some of those rules when we're doing this multi-step problem. So let's go back and take a look. All right, so the first thing you're going to want to do is add up your mass numbers and then divide by 3 to get your average mass, which I calculated out as being 10.1 grams. And remember, when you're doing, we had to add first, but then we divided by 3 to get the average. And when you're doing multiplication and division, the number with the least number of sig figs will be the number that you're going to use in your answer. But actually, let's take a look at that at the end. We'll look at that when we get to the final answer. When you figure out your average for your water displacement, add these 3 together, divide by 3, you get 4.1 milliliters, and then you just got to plug it into your density equation, which is D equals MV, or density equals mass over volume. And when you do that, I ended up with a number like 2.463. But we need to look at the least number of sig figs and the numbers that we're using, which 10.1 has 3 significant figures, 4.1 has 2. So we're going to use 2 sig figs, because when you're doing division, you use the least number of sig figs and the numbers that you're working with, so 2. So we're going to have to round this to 2 sig figs, which is going to give us 2.5 grams per milliliter. Okay, a lot of steps in that problem. Number 4. Out of these pieces of lab equipment, which one would produce the most accurate results for trying to record liquid volume? And your graduated cylinder is going to be the one that has the most breakdown, tons and tons of little lines and units to try to help make it as accurate as possible. So test tubes a lot of times don't have units on them. If they do, they'll be like widely spaced apart. Beakers, depends on the beaker you have, but it's still not going to be as accurate as a graduated cylinder. And the Erlenmeyer flask is very similar to a beaker in that the only difference is it kind of tapers up, but its measurements are kind of the same. So, all right, you need to write this number 0.0140 in proper scientific notation. And let's go back, because this one is another one you got to look at some rules or try to refresh your memory on the rules. So let's go look at my PowerPoint here. What is scientific notation? Of course, it's just an abbreviated way to write a number. You have a coefficient, which is the number you're multiplying by 10 that has it's a exponent with the 10. You're going to be working, of course, with very large, very small numbers in chemistry. So, of course, this is why we do this. So how do you do it? You're going to have to get your coefficient to be somewhere between 1 and 9.99. And that's, again, you're moving your decimal point. Okay, so wherever your decimal point happens to be, like for this number, you're moving it this way to get to create a number that's between 1 and 999. So 6.29. And you have to count the number of times you move that decimal. For this one, we had to move it the opposite direction to try to create that coefficient number between 1 and 9.99. So moving the decimal point that way, again, you count the number of times you move that decimal, because it's going to be used when you figure out what your exponent is for your 10 here. 10 times the power of what? So here's your rules for that. Let's go back and take a look at it. I said if you need a little refresher, you can come back to this page, or you might have to go to YouTube and look at some videos or look at your notes from class. All right, what are we doing? I need to get back to the study guide. There we go. All right, so for this one, we had to move the decimal point 2 times to get it to a number between 1 and 9.99. So our number was 1.4. And again, keep significant figures in mind. So that 0 here on the end is significant. So we're going to keep that 1.40 times. How many times you move that decimal? You moved it twice. And then since we're moving the decimal this way, it's a -2 as your exponent. So that's scientific notation for that. All right, next thing we're going to take a look at is what we call a material safety data sheet. Currently, they're calling these just safety data sheets. You'll see in both ways, MSDS sheets or SDS sheets. They're the same thing. It's basically information that's going to be about a chemical, how to store it, all kinds of information, safety information, anything like if someone gets hurt by the chemical or spill or whatever. So your exam question will have a very similar safety data sheet. However, the question may not be exactly the same, but really you just have to read through it to get the answer. And this question says, how does the SDS sheet advise to keep this chemical stored? Well, as you read through that information, when you get down here, it says keep it in a tightly closed container right there. So that would be your answer for number 6. Number 7 has to do with precise and accurate measurements. Okay, this is like some data, some trials that were taken in a laboratory, and this is like some student data. Student obtained these data points after measuring the mass of an object 3 different times. If the true value of the object's mass was 5.550 grams, describe this data as being accurate, precise, both, or neither. Okay, and in this case, if you look at your numbers, they are all very close together, 6.293, 6.294, 6.295. However, when you compare the data to the actual real answer, 5.550, it's not accurate, okay? So it's not very close to the real number, so we can't say it's accurate, but when you're comparing the data trials that the student did, all of his trials are super close together. So we can say it's precise, but it's not accurate, which could have had something to do with his equipment not being calibrated properly. All right, looking at dimensional analysis. Okay, we're looking at using density. A metal sample has a volume of 10.0 milliliters. The density of the metal is 7.87 grams per milliliter. How would you write the equation to calculate the mass of a sample using dimensional analysis? So here we go, 10.0 milliliters times 7.87 grams per 1 milliliter. That one's pretty easy. All right, number 9, you just have to calculate the number of atoms found in this compound. It's a pretty big compound. You have nickel that sits out here. There's no subscript, so there's only one nickel atom. And then you have C2H3O2. Now, each one of these inside the brackets has got its own total number of atoms, but look what we have outside. We have 4 molecules of C2H3O2. So we have to multiply these numbers inside the brackets times the 4, which is why I have carbon. There's 2 times 4, hydrogen is 3 times 4, and oxygen is 2 times 4. And when you do the math, you ended up with 8, 12, 8, and 1. Add all those together, and there are a total of 29 atoms in that formula. Number 10, the data table describes, or what does the data table below indicate about the substances? So we have substance A and substance B. They both have 8 protons each. One of them has 8 neutrons, but 9 neutrons in substance B, and they both have the same number of electrons. Well, substance A and B are the same element, and we know that because they have the same number of protons. But they must be isotopes. And why do we know that? And that's because isotopes have different number of neutrons. Since they have a different number of neutrons, then substance A and substance B are elements that are the same, but they are isotopes of the same element. Number 11, we're looking at trying to determine the weighted averages for the atomic mass. The element carbon exists as 2 naturally occurring isotopes. You have C12, and that tells you the atomic mass for that isotope. Occurs 98% of the time. And carbon-14, that's the atomic mass for this particular isotope, exists 2% of the time. Write the formula in the correct format for determining the average atomic mass of carbon. So if you remember, you take the atomic mass and you multiply it by the percentage in decimal form. So you got to make sure you turn that 98% here for carbon-12 into a decimal. And then for carbon-14, it's at 2%, so we have to turn that 2% into a decimal. So you just multiply the atomic mass times the decimal for the percentage, and then add all those together for each isotope. You end up with 12 times 0.98 is 11.76, and then 14 times 0.02 is 0.28. Just add those together, and that gives you the weighted average atomic mass for carbon and those isotopes. All right, number 12, gold has a half-life of approximately 3 days. If you start with a 200-gram sample of gold, how much will you have left after 9 days? Okay, remember, half-life is the amount of time it takes for 1/2 of that element to decay. So let me see if this will let me write on here. I'll show you my way of doing this. Hopefully it'll let me write. If not, I guess I can verbally tell you. Okay, so the half-life itself, okay, it's not going to let me write. The half-life itself is 3 days. And it says 9 days have gone by. So how many half-lives is that? 3 goes into 9, how many times? 3 times. So that means 3 half-lives. So you start with a 200-gram sample. Let me see if I can at least type it. So 200, put it in red, 200 we want to half it. I'm trying to think the best way to do this. Divided by 2, I guess. That's 1 half-life. Gives you 100. We said 3 half-lives have passed. All right, so that's 1 half-life. 100 divided by 2 is equal to 50. So this is half-life number 1. Gives you 100. Half-life number 2 gives you 50. And now we got to divide 50 by 2. And that's going to give you 25 grams. Okay, so every time a half-life goes by, you're losing half of that element. So you're just dividing by 2 or multiplying by 50%, however you want to do it each time. But you just got to figure out how many half-lives you have. And in this case, it was 9 days that had passed by. And we said every half-life is 3 days. So 3 divided into 9 is 3 half-lives. All right, physical versus chemical properties. Remember, physical properties are things that don't change the chemical makeup of the substance. If you have a chemical property, if it goes through a chemical change, it actually changes the chemical makeup of the substance. So this question is just asking you which ones are chemical and which ones are physical. So malleability is the physical. The rest of them are all chemical, because something combusts means it burns up. Flammability, same thing. And reactivity, if it's reactive, it means it's going to react with something, create bonds, break bonds. So these are all chemical. All right, number 14, which scientist was the first to experiment showing that atoms have protons in the nucleus using gold foil and alpha particles? That was Ernest Rutherford. Number 15, atoms of the same element must always have the same number of protons. Okay, the proton count will not change. Number 16, a neutral atom of iron 56, and that's just giving you the atomic mass. Contains how many of each? So you would need your periodic table. You would go and you would look at iron. Iron has an atomic number of 26. Now we said this is a neutral atom. So neutral atoms, you can look at that atomic number. It gives you the proton count and the electron count if it's neutral, because that means it has the same number of protons as it does electrons. So 26 for protons, 26 for electrons. And then how do we get neutrons? Well, remember your neutrons are thrown into this atomic mass. Remember your atomic mass, which is the larger number, is protons plus neutrons. So in order to figure out neutrons, you take the atomic mass number and subtract the atomic number from it. So 56 minus 26 gives you 30. So 30 neutrons. All right, mixtures for 17. It wants to know which one is a mixture: carbon, glucose, distilled water, or air. Out of those, air is really the only one that's a mixture of different substances. So that's your answer for 17. Number 18, which of the following is not considered a diatomic molecule? Diatomic molecules are ones that tend to bond to themselves. There's 2 of them together. I can give you the not very appropriate high school mnemonic for that. I'm sure college students came up with this one. The mnemonic is "have no fear of ice cold beer." I wish I could write it down, but again, it's not letting me write. But these are the 7 elements that tend to form diatomic molecules, and that would be hydrogen, nitrogen, fluorine, oxygen, iodine, carbon, and bromine. Thus the mnemonic, the first letter of each one. So out of these 4 that are given, sulfur was not one of those. So sulfur is not considered a diatomic molecule. Number 19, got to remember your rules for naming ionic compounds. Remember, you name the metal first, and then you name the non-metal second, and the non-metal, you have to change the ending to IDE. So KBr, what would that be called? K, if you look on the periodic table, is potassium, and that is our metal. We name that first. Bromine is our non-metal, but we have to change the ending to IDE, and there is your name for this particular molecule there, potassium bromide. Number 20 wants to know what's the correct name for NH4F. Now, NH4 is one of our polyatomic ions. Okay, so when we name a compound using polyatomic ions, you just name the polyatomic ion as a specific name. So NH4 is ammonium. And then, of course, that is the cation, the metal cation. We name that first. And then fluorine is our nonmetal. We name that second, and we still have to change the ending of that one to IDE. So this is ammonium fluoride. All right, 21. It says cobalt is a transition metal, and it can have an oxidation number of either 2 or 3. Remember, your transition metals are those ones that are in the middle of the periodic table that are a little tricky because they have several different states, several different, the number of electrons they give off can vary. And in this case, cobalt can give off either 2 or give away 2 or 3 electrons. So should either of these forms of cobalt bond with oxygen, what are 2 possible chemical formulas? Now, this goes with our crisscross method. Let me take you back out to my PowerPoint real quick. And get to that. Okay, so remember our periodic trends. There's our polyatomic ion. There's our naming. I thought I had something here to help you guys with this. Maybe I didn't. Well, I guess let's go back and look. Cobalt is in this middle section here that you can't see. That's why. This is our periodic trends chart. So it kind of gives you the ionic charges that some of these form. But, okay, so if we look at oxygen, I guess we can look at this for oxygen. See how it normally forms a -2? So we said we had, let me see if it'll let me write on this one. So we said we had cobalt. No, not gonna let me write on this one either. All right, I don't know why it's being like this today. Normally it lets me write. All right. Well, let me go back to my Word document then. All right, so we have oxygen, which is going to be a -2 all the time. It's not going to change. It's going to have a ionic charge of -2. So we have one cobalt that has a 2, so that's going to be +2. So we got CO with a +2 charge along with oxygen with a -2 charge. And remember, if the charge, and we do the crisscross method where you take the superscripts and crisscross them into the subscripts of the adjacent atom. In this case, they're both 2s. So we're going to reduce it, to 1s for each one of them. And remember, if you have a 1 as a superscript or a subscript, you don't write it. So that's how we end up with CO for cobalt and oxygen. There's just one of each. Now, if you end up putting the oxygen with the version of cobalt that forms a 3+ charge, okay, that's going to be the CO with the +3 charge. Oxygen still has the -2 charge, so that's where we do the crisscross. So the CO 3+, the 3 becomes the subscript of the oxygen, and the -2 of oxygen, that 2 becomes the subscript of cobalt, and that's how you end up with CO2O3. Okay, I really wish I could write this, but my computer's being dumb and it won't let me write anything anymore. But you do, remember, you crisscross the superscripts and turn them into the subscripts. So that's how, these are the 2 possible answers for number 21. Number 22, this gives you a name of a formula, iron 3 sulfate. Remember when we put the numbers in the Roman numerals in parentheses, that's telling you that this metal here is a transition metal. Just like we were talking about with cobalt, it has many forms. So this is telling you what form it's coming in. So this would be the iron with a 3+ charge. With sulfate, on the other hand, sulfate is normally SO4 with a -2 charge. So again, we do the crisscross, and that's where you end up with the 3 in the subscript here for sulfate, because you're taking that where the iron had the 3+ charge, doing the crisscross, end up with the 3 for the subscript here. And then the sulfate itself had a -2 charge. You do the crisscross, bringing that down, it becomes the subscript for iron. Crisscross. Hopefully you guys remember that. I really apologize. I don't know why it won't let me write on this board anymore. Well, I guess I could take it out to the whiteboard, couldn't I? Let me do that because I know some people are a little confused. Let me stop sharing here. And I'm going to go to the whiteboard. Let's see if it'll let me write there. All right, so I'm going to go back and real quick, if this will let me. It's being kind of weird here too. Let's go back and look at 21. All right, and it's still not letting me write. Oh, not even gonna let me write on the whiteboard. All right, guys, I apologize. I don't know what his problem is. All right. Let's see. Number 23, which one of these compounds contains both an ionic and a covalent bond? Remember, ionics are the ones that are going to have the oppositely charged ions together, the metals giving away the electrons, the nonmetals accepting them, and you get the positive and the negatives attracting. The covalent bonds are the ones where they're sharing electrons between atoms. So our answer would be this one right here, your ammonium chloride. And that's because the nitrogen with the 4 hydrogens and the ammonium, they're going to be held together by covalent bonds. But in order to get this ammonium that has a plus charge to attract to the chlorine, which has a negative charge, that's going to be the ionic bond part. Okay. 24, what is the correct IUPAC name for? We have CCl4. So remember, you name your metal. I'm sorry, this is covalent bond. So you're going to name that carbon first, and then the chlorine second. We still change the chlorine to an IDE at the end, but now we're looking at covalent molecules. So we're going to be using those prefixes. Well, since there's only one carbon, and remember, we don't use mono. Remember, mono, di, tri, tetra, those are the prefixes you would be using. There's just one carbon, but when you're naming that first molecule, you don't put mono on it. So we leave the mono off. So it's just carbon. And then there are 4 chlorines. So that's tetra for the 4 part, and it's chloride. So carbon tetrachloride. Looking at number 25, what's the correct molecular shape for the following molecule? So we have nitrogen bound to 3 hydrogens. That's going to give you that triagonal pyramid shape. Again, I wish I could draw that for you guys, but actually I think I have it in my PowerPoint where you can at least see the picture. Hold on, let me go look at that. Yeah, since I can't draw it, you can at least see it right here. Triagonal. You'll see right here the okay, not the pyramid. Hold on a second. I need to go back. It's triagonal planar. I just realized I put the wrong word in there. That should say planar. Okay. So go back and let you see that one more time. Let me show you this. So it should say triagonal planar. And here's the picture of it right here. Okay. Or did I have it right the first time? Hold on, guys. I think I may have had it right the first time. That was NH3. I don't know what I'm thinking. NH3 is right here. I had it right. Triagonal pyramid, or trigonal pyramid. I'm sorry, trigonal pyramid. I did have it right the first time. Right here, because it's NH3. So you have the N with the 3 hydrogens down here. Okay, so trigonal pyramid. Trigonal pyramid. Let me go back to my screen. Everybody needs to go back and take a look. It's trigonal pyramid. Trigonal pyramid. I did have pyramid right. It was the first word that I had spelled wrong. All right, trigonal pyramid. Make sure you fix that. All right, number 26. They want to know the correct name of P2O5. So this is phosphorus. So we name that first. And then we have oxygen. Remember, change the end of oxygen to IDE, so oxide. And then we have to look, since this is a covalent compound, we're going to put our prefixes in. There's 2 phosphorus, so the prefix for 2 is di, so it's diphosphorus. And there's 5 oxygen, so pentoxide. Diphosphorus pentoxide for that one. 27 wants you to give the formula for the name. So we have dinitrogen pentoxide. So di again means 2, but this time it's nitrogen. So you have 2 nitrogens, and then it's still oxide, so that's oxygen, and there's still 5 of those, so O5, N2O5 for that one. All right, this next one. 3 elements, X, Y, and Z, have consecutive increasing atomic numbers. If element X is a noble gas, what will be the symbol for the ion of element Z? Okay, you're going to need your ion forming tendencies table for this. Let me see if I can get this to come up. I think it's in my PowerPoint. Yeah, right here. We'll use this. All right, so it said you had elements, where is it? X, Y, and Z, and they're consecutive, which means they're back to back to back on the periodic table. But it says element X is the noble gas. Okay, so your noble gases are here. So here's element X. And then Y and Z, remember you read the periodic table, when you get to the end, you have to go back down to the next row and start at the beginning. So if this is X, then this is Y and Z. Okay, the question was, what will the symbol for the ion be for element Z? Well, element Z is in this column right here. It would be, you know, one of these. So regardless of which one it is, look at what its charge would be. It would be a +2. Okay, so that's how you do that. So our answer for that one was Z with a +2 charge. Okay. 29, chlorine forms a -1 ion, or 1 negative ion. How many electrons does chlorine have? All right, let's go look at that periodic table. Just want to look at a regular periodic table now. Let's see, there we go. So look at chlorine. Chlorine has an atomic number of 17. So chlorine in a neutral state has 17 electrons. But we said it has a -1 charge. That's telling you it's a negative ion that has gained 1 electron. So if it normally has 17 electrons and it has gained an electron, how many electrons does it have now? It has 18. All right, number 30 has to do, and 30 and 32 have to do with electron configuration. Okay, N is representing those numbers that represent the energy levels, so we're really not putting those numbers in. You're just really looking at the S's and the P's, and they want to know, with N representing the outermost energy level, the electron configuration for that level for elements in group 16 is what. So you guys remember, don't forget your electron configuration periodic table. Okay, you remember the 1s, 1 and 2, 2s, 1 and 2, 2p goes all the way to 6, 3s, 1 and 2, 3p, and so on and so forth. So your answer for number 30, it asks you for group 16. So group 16 is right here. So that would be 2p. Remember, we don't put the number in front, so it'd be p, 1, 2, 3, and 4. So you have both S's, so that's S2, and then it's P4. Okay, because this is group 16. All right. So that's how we get this answer, NS2 and P4. 31, what scientist was the first to propose that an atom has electrons in discrete energy levels? That was Niels Bohr. Another electron configuration, an element has an electron configuration with this right here. Which of these will be in the same group? Well, it's letter B, and really you could go through and figure out what each one of these elements were. But if you look at the end here, ends with 3s2, look for the one that ends in s2, and there's really just this one right here. Okay, which that would be group 2. All right, if you remember your periodic trends from left to right across the periodic table, what change is occurring within the atomic nuclei? The nuclei decreases in size as you move from left to right. So it gets smaller. Number 34, which of these elements have the smallest atomic radius? If you looked at the periodic table to see where all these elements were, oxygen is the one that's up in that right corner. So we said it decreases in size from left to right. So the further you get to the right side, the smaller they are. So oxygen would be the smallest. And then 35 says discuss the trend in ionization energy. Let me go back and show you all that periodic table. Remember your trends. So we're looking at ionization energy. Okay, so it increases going from left to right and from bottom to top. Okay, so that's your answer for the last one. Ionization energy increases from left to right and from bottom to top. Okay, I hope I without being able to write on anything, I apologize, guys. But I hope this helps you. And if you have questions, hopefully you can you'll email me. Okay, guys, you have an excellent day and good luck on your exams.